All right, everyone, get ready, because today we're taking a deep dive into something that's probably way more interesting than it sounds at first. We're talking about period.
In physics, of course.
Exactly, in physics. And look, I know what you're thinking, period, like the punctuation mark. But trust me on this one, we're going to uncover some real aha moments that will totally change how you see the everyday world around you. We're digging into this super clear, very straight to the point physics review guide. And that's just how we like them here.
Concise and insightful. I'm already excited.
Me too. And to help us break it all down, we've got our physics pro expert speaker with us today.
Happy to be here.
Okay, so this guide, it defines period as the time required to complete a single cycle. Which, all right, sounds simple enough on the surface, but what's that actually look like, like in motion?
Think of it like a heartbeat, but for anything in motion, really.
Okay.
The swing of a pendulum, back and forth. Or the orbit of the moon, that whole journey around the Earth. They each have their own rhythm, their own period. It's that predictable, repeating interval, and it's what defines their movement.
Rhythm. I like that. So it's not just about time then. It's about a repeating pattern, right? Like if you think of it musically.
Yeah, absolutely.
Like a dance move that just keeps coming back around.
Exactly. You got it. That repetition, that's the key. It's what makes a period different from just any random chunk of time.
And speaking of examples, our handy-dandy guide here, it points to the moon's orbit, right, which of course takes about 28 days. But then, get this, it also mentions a high school class. Does a class really have a period?
Think about it. The bell rings, class starts, it runs for about, 50 minutes? Then the bell rings again, it's on to the next one. That's a repeating cycle within the school day.
Yeah.
It might not be as, cosmic as the moon's orbit, but the principle's the same.
Oh, yeah.
A set amount of time for one complete cycle.
Wow, I never even thought about it like that before. So even things that we don't usually think of as having a cycle, they actually do. That's really cool.
Absolutely. Now let's take a second to shift gears a bit and talk about sound. Because a sound wave, it's basically a really, really fast back and forth vibration of air molecules.
And sorry to interrupt, but just to be super clear for our listeners, by vibration, we're talking about that super fast back and forth movement, right?
Exactly.
It's like, okay, just making sure.
Yes. And the time it takes for one complete vibration, one full back and forth, that is the period of a sound wave. And guess what? That period is what determines the pitch we hear.
Hold on. So are you saying that faster vibrations would mean a higher pitch?
You got it. Shorter periods, faster vibrations, those molecules are zipping back and forth, and we hear a higher pitch. Now, longer periods, on the other hand, mean slower vibrations. And that translates to a lower pitch.
It's like when you see like visualizations of sound waves on a screen, right? Like those peaks and valleys, one complete up and down, that's the period.
Exactly.
It's crazy that we can actually visualize something like that,
It really is. And another cool thing, it doesn't really matter where you start measuring on that wave, as long as you capture one full cycle back to the same point.
Makes sense. So it's about that complete cycle, not just a random chunk of time, which actually kind of makes me wonder about something. Our guide here, it mentions this unit, USEC. Can you break that down for us?
Sure. USEC stands for microseconds, which is 1/1,000,000th of a second.
Wow.
So we're talking incredibly fast periods here, especially when we're dealing with things like sound waves, light waves, that kind of thing.
And I'm glad I don't have to do those calculations by hand. So we've got these teeny tiny periods being measured, but where do these periods even come from in the first place? Like, the guide says the sound source determines the period, but what does that even mean?
That's a great question. Basically, it all boils down to the inherent properties of the source itself. For example, a thicker guitar string, it's going to vibrate slower than a thin one. So that means it's going to have a lower pitch, longer period. See? It's all connected.
That is wild. So you're telling me everything is basically out here vibrating at its own, like, predetermined speed based on what it is?
Essentially, yes.
Yeah.
Like, for a pendulum, it's the length and the pull of gravity that determine its period. For a star, way out there in space, its mass and the gravitational forces acting on it, that dictate its period. It's not something we can just, change on a whim. It's all dictated by the laws of physics.
Wait a minute. So does that mean, like, even my thoughts have a period?
Now you're getting into the philosophy of consciousness.
That's kind of trippy to think about.
It is. But it's that kind of thinking, that helps us appreciate how pervasive this concept of period really is.
It really is. So whether it's the, hum of our laptops or the spin of our entire galaxy, everything has a period. A hidden rhythm governed by the laws of physics. That's mind-blowing.
It is mind-blowing. It shows you that physics is constantly at play, even in the things we take for granted.
I'm officially fascinated by periods now, and a huge thanks to you, expert speaker, for, breaking it all down and making it so engaging.
You got it.
And for our listeners, be sure to join us next time as we deep dive into another fascinating topic. Until then, keep those brainwaves humming.